Welcome to another exciting tutorial. In today's video, we will dive into the world of 3D flight simulation using Java. Whether you're a beginner or an experienced developer, this tutorial will guide you through each step to create your very own flight simulator. We'll be using a library called Java 3D. First, let's make sure you have the necessary tools installed. You need to have the Java Development Kit, JDK, and the Java 3D library. First, ensure that you have the latest JDK installed on your machine. You can download it from the official Oracle website. Once that's set up, go ahead and add the Java 3D library to your project. You can do this by adding the necessary JR files to your class path. Now that we have our environment set, let's start by creating a basic window where our simulator will run. We will set up a simple JFrame. In this code, we import the necessary swing components and create a JFrame with the title 3D Flight Simulator. We set the size and define the close operation. Finally, we make the frame visible. Next, let's integrate the Java 3D library to render graphics inside our JFrame. We will create a simple canvas that will serve as our drawing area. We have now added a Canvas 3D, which acts as a surface for rendering 3D graphics. It utilizes the Simple Universe class for preferred configuration. Let's add a basic 3D object to our scene. For this, we will create a simple cube using the box class from the Java 3D library. In this updated code, we created a box which represents our cube. We add this cube to a branch group, which is a structure that allows us to manage a group of related objects in our scene. To enhance our scene, let's add a light source so that we can see the cube clearly. We'll use the Directional Light class from the Java 3D library. In this code snippet, we create a new directional light and set its color to white. We also define the direction from which the light will emanate. This light is then added to the branch group containing our cube. Let's put our light and cube together and create a more complex scene. We will adjust the camera position to have a better view of our cube. Here, we set the nominal viewing transform, which establishes the initial view of the scene. Then we create a transform 3D object to move the camera back along the z-axis, giving us a better view of the cube from a distance. Now, let's add keyboard controls to allow us to manipulate the view of the flight simulator. We'll listen for key events. In this code, we add a key listener to the canvas. We check if the up or down keys are pressed and adjust the camera's vertical position in response. This is just a simple demonstration. In the complete simulator, we could have multiple controls. Moving forward, let's create movement in our flight simulator. We'll implement a basic flight model. For this, we need a method that updates the camera position based on keyboard input. This empty method will be responsible for calculating the new position of the camera based on user inputs. For now, it's a placeholder that we will fill in as we provide functionality later. Next, we will encapsulate our flight physics. Basic physics will allow us to simulate flight dynamics, such as pitch and yaw, which correspond to how a plane moves in the sky. Here we define two float variables for pitch and yaw. Using these, we control the rotation of the camera based on key presses. The left and right arrow keys will control yaw, while A and D will control pitch. Let's update our update position method to translate our pitch and yaw adjustments into camera transformations. That way, we can see the camera angle change as we control the flight. With this method, we apply rotations based on the pitch and yaw, followed by a translation to simulate the camera moving backward. This creates a feeling of flying forward in our simulation. Now we can render it all together. When a key is pressed, our viewing position will adjust accordingly, providing a basic flight simulation experience. Let's take the simulation a step further. Currently, we are in a static environment with just a cube. To enhance the visuals, we will add a skybox. A skybox provides a panoramic view of the environment surrounding our flight. This method loads a texture and applies it to a large sphere around our scene that acts as a skybox. This will give our flight simulator a more immersive feel with a surrounding environment. Let's also consider adding terrain. To simulate the ground below, we can create a simple grid of colored geometries. For our terrain, we might use a simple plane. In this method, we create a quad array to represent our terrain. We set the coordinates for its vertices and assign a green color to create the appearance of grass or ground. We can now compile all of our methods into the main class and call them in main. to create a complete environment. In this code, we're calling our initialize method, which will set up the skybox and terrain alongside the rest of our scene. Make sure the textures are accessible in your project directory. Finally, let's make our flight simulator interactive. We'll implement a method to manage continuous updates on our flight controls and camera adjustments. This run method allows us to create a loop, updating our position continuously. The thread.sleep ensures we aren't consuming too much CPU, controlling the frame rate of our simulation. And there you have it. You've created a basic 3D flight simulator in Java with Java 3D. You can move your camera around, visualize your environment, and simulate a flight experience. This was just the beginning. You can further enhance it by adding more complex physics, enhancing the scenery, or even incorporating flight dynamics. The sky is the limit. Remember to like this video and subscribe for more tutorials.